No? So I have it here. I'm happy to talk about any of these that we need to. So what sorts of issues did you have with your averages? Okay, wait, Americo. I had to think for a minute, sorry. Let me look. The C part, but you got the other part. Okay, well, the other part, you're halfway there. So yeah, let's take a look. Let's take a look at number 9, just for an example, if that's okay. Unless you have a favorite. Do you have a favorite? 9's good, yeah, because they're all similar. So let's take a peek at 9. And then if we do 9, probably, because if you've done yeah, that's something else. Let's see. If you've done the average, then you're halfway there. You're almost there. So with number 9, the question is, we're looking for the average value of x minus 3 squared. Let me write this down. X minus 3 quantity squared between 2 and 5. So I need to do the work so that I can answer the question, if that's okay. So the average, F AVG, we could write it like that because that's the way the book does, is going to be 1 over 5 minus 2. So this is all pretty straightforward. 1 over the length of the interval. That's like when you add up numbers and divide by the number of numbers. This is the dividing by the number of numbers part. And then we're going to multiply by the integral. This is the adding up from 2 to 5 of this function. And I'm going to forego the joy of doing integration by substitution because this one's not a hard one. You end up with x minus 3. Wait, is this cubed? Is it cubed? It is squared. Okay, good. It's squared. I thought for a minute that I'd messed up. Okay, x minus 3. So this will be this after doing your substitution. If you don't believe me, go ahead and do your substitution. But that's not a hard substitute. That is u equals x minus 3, du is dx. So it's not a hard substitution. Anyway, if you believe me about that, then the rest of this should be pretty straightforward. And we end up with 1/3 times. Let's plug 5 into this thing. When you plug 5 into this thing, we get, let's see, 5 minus 3 is 2. 2 cubed is 8. Let me know if I get any of this wrong. And then I plug 2 into this thing, I get -1. -1 cubed is -1 over 3. And all of that together, I believe, is 1. Is that what you got, Americo? Okay, just wanted to get some verification because, as you know, I'm trying to, keep that mental calculator working properly, and I'm not always trusting that it is. Okay, so now that we've got that, so this is part A, by the way. This is number 9, part A. Part B and C, and of course, if you can't do B, then C doesn't make any sense. So part B asks, find a C so that the average is equal to f of C. So let's actually do precisely what they say here. So this number here is f AVG. So I'll just write that down. Oh, so this is B. And it says, find a C so that that number is equal to f of C. So f of C. Well, what's f of C? Well, f of C is what you get if you take C and plug it into this wherever you see an x. So let's do that. 1 is equal to C minus 3 squared. So instead of x minus 3, I just have C minus 3. So that's all it's asking you to do. I'm sure you could solve this equation. I'm going to do it, though, because we got to get for part C. So at this point, yeah, super easy. So you know the deal here is that we could do it one of 2 ways. I'm going to do it the easy, cheesy way, if you don't mind, and that is just do the square root of both sides. And when you do the square root of something squared, you have to put a plus or minus somewhere. The other option, by the way, is to square this binomial. You'll get a trinomial, and then take the 1 and then solve it. It's a quadratic, basically. But either way, we're going to get C is equal to, let's see, that'll be +4, or C is equal to +2, not negative, +2. So are those, I think those are the correct numbers. So it's either +4 or +2 as my two answers. Let me just show you the other way, because you might think, wait a minute, you're pulling the wool over my eyes. Surely it's not that easy. So let's just do the other way as well. 1 is equal to c squared minus 6c plus 9. So if you're really into doing quadratic equations and factoring, this is the way you should do it. So 0 is equal to c squared minus 6c plus 8. And then you get 0 is equal to c minus 4 times c minus 2. Because 2 times 4 is 8, and 2 plus 4 is 6. You know how to factor, don't you? And then, so that gives you the same, here, I'll just go down there. So there it is. So that's part B. So that makes sense, Americo? Yeah, so you do the same thing for the other two that I had you do, which there may be some algebraic problems, but you're just setting up an algebraic equation here and solving. You know, I got to finish this one. Since I've already done parts A and B, let's do part C. So part C, actually, I didn't finish this, did I? We are being asked for one or more points. Is that the deal? One or more points. Yeah, one or more points in that interval. So I guess that, does it, sorry, find C. Yeah, it doesn't say. So I guess both of those are inside the interval that we're looking for. So if one of them had been outside the interval, you would exclude that from your answer. So there they are, they're both there. Now let's do part C, because part C is kind of fun. So first things first, I need to graph y is equal to x minus 3 quantity squared. I don't know if you remember this from your pre-calculus days, but in pre-calculus you probably learned how to shift a function along the x-axis. And this is a x shift. Then minus 3 shifts the function 3 units this way. So it's the opposite of what you'd expect. So if you have a function that you already know about, for example, y is equal to x squared, which I'll draw. Here's y equals x squared. Then this shift, let's see. Okay, good enough. I don't know if that's a perfect, it's fine. So the shift, x minus 3, just moves it over. It's not entirely important for you to remember that, but there you go. So that's what this function looks like. And then we're only interested in the range between x equals 2 and x equals 5. So it's that range. And it turns out that the average value of this particular function is 1. And if you draw a rectangle on this curve right there, which is 1 unit high, you'll find that it intersects at 2 and at 4. So that's just kind of an interesting curiosity. I don't know how useful that is for us, but it's kind of cool that, that you have that situation. All right, are you happy, Americo? That's all I can ask for. All right, so what other things do we need to talk about with this homework? Yeah, what do you think, Maggie? Certainly. So 12 is in the same section. We're doing the same thing. It also has a little icon next to it that says, you might want to use a graphing calculator. I refuse. But you can if you want to. So let's do this one. 2x e to the negative x squared between 0 and 2. So give me a sec. Let's take a look at 12. Y is equal to 2x e to the negative x squared. And this is going to be between 0 and 2. Did I get it all right? Okay. All right. Well, okay. Here's what I guess I don't trust myself. I'm going to grab my calculator. I mean, I'll give it a go. We'll see how closely I get to the actual graph. Does this one work? Oh, it does. Okay. Okay. So let me give it a go. See if I can remember what this is going to look like. Oh, and you might wonder, how are you going to figure this out? Well, it's because e to the negative x squared, I know what that looks like. That looks something like this. It looks like it's not a normal curve, but it looks like a normal curve. So it's sort of like that, like a bell curve almost. And then when you multiply that, so that's the e to the negative x squared. When you multiply it by 2x, what's going to happen is at 0, of course, 0 times anything is 0. So you're going to start here, but then you're going to get a little hump. I don't know what the concavity is here, but I'm just going to guess it goes something like this. And then because e to the negative x squared is so huge, it's just going to taper off. So the blue curve is what I'm guessing. Let's see how close I am to correct for this one. Y is equal to, bear with me, and thank you for letting me amuse myself in this way. E to the, let's see, negative x squared. Let's see, and I need to change my window. X min is 0, X max is 3. I'll just do. I don't know what my window should be. Ooh, hey, I was pretty close. Here, just I gotta adjust my window. I don't know if I want to show it off that much, but oh, that's amazing. Oh, I love it. I'm just so happy. Okay, so here, I'll take a picture of it. Maybe, if it'll let me. See, camera that baby. Oh yeah. Look at that. Look at that. I got to take my victories where I can. Okay, so thank you for letting me amuse myself. I'm almost perfect, but anyway, yeah, it's not important that you're able to do that. Yeah, let's get rid of the purple. So now what are we doing with this? It's from 0 to 2, so 2 is over here somewhere. So there's the situation, and we're going to do the average. And the main issue that you're going to have with this is the integral. So let's go ahead. This won't take too long. I hope you recognize that as being an integral that will succumb to integration by substitution pretty easily, but I'll do it just to remind you, because you will have, by the way, on your exam, if you haven't yet looked at that practice test, I have integration by substitution on it, and some of you had a little trouble when we were doing it earlier. So just it's a reminder. I know you did it in Calc 1, but I want to make sure that it's solid, that you're on solid ground as we go to all of these applications. So first things first, we're going to let u equal negative x squared. Du is negative 2x dx, and then you know how I am. I insist, at least for myself, to always rewrite my integral there. So here's what I did. I just wrote the 1/2 there. I needed a negative in front of the 2x, so negative 2x. But that negative can't just come out of nowhere. It has to, be matched with another negative. So there's that. So now I can do my substitution. So let's do that. Super easy now. So this is negative 1/2 times the integral of e to the u du. And we all know what that is. E to the u plus c. Well, we don't need the plus c because this is a definite integral. Then let's go back to x. Is it x? Yes. So this will be negative 1/2 e to the negative x squared, evaluated from 0 to 2. So let's see what this is. Negative 1/2 e to the negative x squared, 4. Sorry. Minus negative 1/2. So that'll be plus. Okay, so it'll be 1 minus e to the negative 4 over 2. Let me just get rid of this. We don't need it. Okay, so this is the average. Oh, I just realized that might not be the problem. Is that not the problem? Okay, it's the next one. I just realized, ooh, something bad is coming. Okay, I feel just as bad about it as you do. Okay, let's see if I can figure it out though. I guess I will have to use the calculator for this. So that's F average, and then we're going to set that equal to 2c e to the negative c squared. So all I did there was I took my function and I replaced all of the x's with c's. Not going to happen. Sorry. So here's what's going to happen actually. Is I guess that little red icon that has the little graph, I need to pay more heed to that, because what that means is that you're not going to be able to do this unless you use a graphing calculator. So let me show you how I would do it on my graphing calculator. Give me a sec. I just need to set this up and then I'll show you what I have. I guess I could, no, it's so awkward. I'll just put it here. What I'm doing is I'm going into the graphing menu and I am putting the number 1 minus, give me a sec here, 1 minus e to the -4, oh, yeah, -4, all over 2 as a function. So this will be a constant function so that when I graph this, you're going to see a horizontal line show up. Let me just switch over to my camera, my real camera. There it is. So that you can see. So you see the horizontal line. So just so you know, this was that. So you see I put the constant in there. Now you can see that horizontal line. And then I think one of these buttons will let me, I'm not really good with this stuff. Oh, intersect. I'm guessing it's intersect. Doesn't that sound right? So let's use intersect. That's the first curve. Sorry, hit enter. I know it looks, you're getting dizzy. Here's the second curve. I'll just use this as my guess and let's see what happens. Ah, there it is. Intersection is at x equals 1.2874. So that's what you should have done. Sorry. And you could do the same thing, move over to the other with your guess and get the other one. If you want to know what your calculator is doing while it's doing this, you can take a course that we have here called Numerical Methods. And in Numerical Methods, actually right now, yesterday, we were talking about a method called the fixed point iteration method, which actually helps you solve equations like this, finding intersections and so forth. So that's what your calculator is doing. It's using a numerical method. It's probably not the fixed point. It's probably Newton's method, to be honest. But there it is. So I apologize. I will pay more heed to those little red icons in the future, and maybe we'll avoid them. All right, anything else, or are we ready to move on? Oh, I should have mentioned at the beginning, there's a meeting after this that I need to be at early. So we're going to end around 10. So you can be excited about that. Yes, Michael's like, you should be like, wait a minute, that's 10 minutes that you're not going to, you owe me 10 minutes worth of, okay, I'll make a video, all right? And we'll put it online. So anyway, yeah, so I'm just looking at the clock, making sure. Okay, so no other questions, good. I don't have a quiz for this particular thing, but I think it's easy enough that you're not going to have a problem with it. I would direct your attention to the practice test. I do have a quiz, but it says quiz, but it's really homework, just more practice to have fun. So what we're doing today is going back sort of to mass and force, because there's one more issue that has to do with mass and force that we didn't get to, and it's kind of an interesting thing. And so I thought we'll do this. I'll give you this, and then we'll call it a day. So mass and force. So mass, and I hope you're starting to sense the pattern in each of our cases here with these applications. Is we take whatever it is that we're interested in and chop it up into little pieces, and then add up the little pieces. That's the program. That's the thing that we do in Calculus 2. We're always doing that. And so when we're talking about mass of an object with a variable density, then what we can do is we can do the same thing. Chop it up, add them up. So, whoops, there it is. Oh, yeah. So this is the mass. So you're used to this. Volume times density is mass, hopefully, from some time in your past, either chemistry or physics, you learned about mass is volume times density. So when we're talking about a linear object, like a wire or a rope or something long and skinny, then instead of thinking in terms of volume times density, we could think in terms of length times density. And that just is, if you have something like this, I don't know what it would be, but like some long straight object. And if for whatever reason, the density changes as like it's more dense over here and less dense. Not to worry, I actually have, in just a minute, we'll have an actual object. I should have brought one with me, but I didn't, but something that you are all familiar with that you can imagine. It's not a straight line, but it will help us with this. So anyway, there's the mass times density. So that's what we're talking about, is you have something like this that changes density as you go left and right. And of course, I think you know what we're going to do is we're going to chop this up into little pieces. We'll have delta x. We will compute the mass of each little piece, and then we will add them up and end up with an integral. So that's it. Oh, okay, we're pretty much done now. Oh no, we aren't. Let's do this. So rho. Rho is the symbol that we use for density, and density can take on different forms. So at some point, I see. I get all the calculi confused. I think we will before spring break. I think we will talk about lamina density, which is the density of a flat object. So density in that context would be mass per unit area. And actually, every time, if you ever work with paper, like copy paper, yeah, I mean, like you buy a piece of copy paper, like a ream, it will have pounds, like 20-pound bond, 15-pound bond. That is actually a lamina density. So that, I don't know exactly what the units are, but it's number of pounds per unit area. This is number of pounds or number of kilograms per unit length. That's that density. But in each case, rho, I know it looks like a funky P, that's density. Okay, so, yeah, rho is, what? Oh yeah, rho of x is because of this, rho of x happens to be the derivative of the mass, which is kind of interesting. But here's what we want to do. So let's actually do this with this particular problem, not a hard problem. I've got another one for you that you can take with you. I want the mass of a part of a rod that lies between its left end point and x meters to the right is 2x squared kilograms. Wait a minute. What is this? Why did it? The mass. Oh, because of this. Okay, that's why that's there. Yeah, because we're given the mass. In other words, we have this long straight object. And so if you take, like this, put an X there. If you take that portion of this rod, then the mass of that rod, mass, would equal 2x squared kilograms. So that's what that means. Okay, so let's put it together here and we will figure out, what are we going to figure out? It doesn't say. I guess we'll do this, that the density of that rod is going to be the derivative of this, which is 4x, and that's kilograms per unit length. So per meter, yeah, so 4x kilograms per meter. That wasn't very exciting. But now we could have, if we have that density, we could figure out the mass of any portion of that rod. So going back here, let's say that this rod, that's a terrible picture, I need to draw it over here. So you have this rod, and on it, so you have the left end point, and so the density is 4x, whatever the units are, kilograms per meter. So let's just suppose that I want to figure out the mass of this portion of the rod between 1 and 2 meters. So in that case, we're just going to do the integral from 1 to 2 of 4x dx. This is essentially what would happen if we were to break this into little bits and multiply the delta x. So here's, if you want to see the summation, you have the summation of the density times how long you have how big of a piece it is, and you're adding these up, and that becomes this. So it's super easy. So then this really isn't too hard. I'll just do it for you. 2x squared evaluated from 1 to 2, which is equal to 8 minus 2, or 6. So there it is. Whew. All right. Let's move on. Let's see. Okay, there it is. Okay, so things get a little bit more interesting when we talk about circular objects with what's called a radial density. So here's where we can actually have something that you are familiar with. So some of you are disc golf players, are you not? Okay, maybe not. Yes, at least a few. Good, good. So disc golf, you know, it's like a semi-solid. It's sort of flexy, but it's a pretty solid disc, and it has the density as you move out from the center varies. Here's what you might see for the cross section of a particular disc is something like this. And don't ask me if this is a putter or a distance or a drive. I'm sure it's not a driver, but it might be like this. If you look at, like, if you sliced it in half, so this is actually this disc here, and you have sort of this rim around here. I don't know. So yeah, different discs have different profiles. Like they're straight up. My kids are into this, and I have a set of these at home because I love them and want to play with them. But I don't remember. I think the drivers are more, they taper at the end, don't they? Like they come to a little point. So I don't know. But whatever. So you have this situation where the density, it's the radial density, and what that means is that how dense is the material at a certain radius from the center, so that when you get out here, like out here, the density is much higher. The disk is thicker. When you're in the middle, the disk is smaller. So what I want to do is I want to come up with the mass of an object based on its radial density. So whoops, I'll just leave it as a mystery for now because it's going to be behind my drawing. So here's how we're going to do this: is we'll start in the middle here, and or we'll call x goes this way, and rho of x is the radial density. All that means is that the density is changing, but it's changing the same as you go away in all directions. So whatever direction you're going away from the center, the density is going to be the same. Now what we want to do is we want to come up with the mass of this object. So here's what I'll propose to you is, since we'll call this x. So delta x is some sort of thickness of that thing there. So how thick is it? And then you have to sort of imagine that you're x units away from the center. And what you're going to have at that distance is a long, sort of skinny strip, almost like a wire. So you have this long, skinny, whatever, there it is. So now what we need to do is we need to figure out the density of that long, skinny piece. And so here's how we'll do it, or the mass of that long, skinny piece. So the way we'll do it is we will just figure out how long it is. That's 2 pi r is how long that is, all the way around. And then the, whoops, sorry. Where did it go? My fat hand touched something, I think. Okay, so 2 pi r is how long that thing is around, multiplied by how thick it is, and then we'll multiply that by the density. So that's how you're going to use the density. Anyway, I'm only showing you this just to sort of emphasize that each time we use the idea of calculus, you're going to be, I'll tell you later. Yeah, each time you use calculus to figure out a problem, you can use this trick in a lot of different settings, and it'll work for you. That is, break up your problem into little tiny incremental pieces and then do a limit. Imagine making those pieces get skinnier and skinnier. Okay, so then down here, this will magically appear, but it's hard to see. Did I miss the x? What is the x for? 2 pi x. Oh, that's the radius. Yes, that's the radius. Sorry. Yeah, the x is the radius. So yeah, it's kind of behind my thing there. But that'll give you the mass of this disk. And so if you knew the profile of your particular disk, this is not going to be such a thing. But if your disk was this, then we could figure out the mass of that disk. The way I would do it is I would do the integral from 0 to pi, because this says that the radius of the whole disk is pi, times 2 pi x times the density, sine of x squared dx. This is not hard to do. Hopefully you could probably do it in your head, but I'm going to actually do it more slowly, but not too much slowly, because we have one more thing to talk about, and then we'll be done. So 0 to pi of, let me get this right, 2x, oh, sorry. Come on, don't tell me that's working. Sorry, the thing is not, darn. Okay, I'll just cross it out. I can't get my menu to work. I'm punching it with my, let's see, what if I do this? Yeah, still not. It sometimes does this. Whatever. Well, anyway, so this will be sine of x squared times 2x dx. So maybe this is to the point, you might be to the point where you can do integration by substitution in your head. Some of us, u equals x squared, du is equal to this stuff. So you're just going to do the cosine or the sine of u. The integral of sine of u is negative cosine of u. So if you don't mind, I'll just do that. So this stuff will be pi times negative cosine of u, which is cosine of x squared, evaluated from 0 to pi. Once again, if you need to write out, I just don't have enough room on this slide. And then this will give me pi times negative cosine of pi squared minus the negative cosine of 0, but we all know the cosine of 0 is 1. So that'll be it. And that's going to be whatever this is. I'd have to use a calculator because I don't know the cosine of pi squared offhand. All right, so that's it. Just wanted to show you two. I have one more thing to show you, and it's actually on this page. So why don't I grab that right here? Did I put it over here yet? I don't think. Yeah, I did. So this is, I'm going to give you this page just to show you here, but you can start reading if you'd like. So let me give you this, and this will constitute the homework as well. But just one more example of how you can use this idea of breaking things into little rectangles. That is our theme. Break things into little rectangles, add them up, and then turn it into an integral. I guess I should put this online and you could download it and put it on there. Well, too late now. Okay, there's this. Maybe in the future I'll try to remember to do that, Michael. I guess, oh yeah, we have a couple other people. You have an iPad. Nice. 1, 2, 3, 4. Come on, there we are. 1, 2, 3, 4. There. Oh, I have plenty of writing utensils up here. If you ever need one, thank you though. There's this beautiful sculpture that I made, and you might even notice on the bottom it has my brand on it. So. Okay. Anyway, trademarked. No, just kidding. Okay, so solid. So I brought a couple of different solids here. So the solids that we've been working with up till now have had circular cross sections. They're discs, they're washers, they're shells, but that's not the only type. Take a look at this one. This one has triangular cross sections. You can kind of see here that this thing, it's the way that they put this together is that it's got these triangular cross sections. This one has square cross sections. So this thing here has square cross sections. So we don't have to limit ourselves to the simple things. I think I might have mentioned at the beginning that those are just sort of classic problems to get you to learn how to think this way. Don't worry, on the test I have the classics. I'm not going to make it interesting because I know you guys like boring tests. But anyway, this one's more interesting though. So let's take a look at this. I'll get you started on it, and then you'll finish it on your homework. But we're going to pretty much do most of it, and then we'll be all done for the day, as the time is waning. So we have a solid with a triangular cross section. That means that each of the cross sections, each time you take this rectangle and you sort of, if you imagine you're looking down on this, but if you imagine sort of turning your head on it to the side and rotating, you'll see this thing down, this giant triangle down there. So you have these triangular cross sections. And let's see, they're perpendicular to the x-axis, which we've got the base of one of those triangles. Each triangle's height is half of its base. and the base of the solid of the region is this yellow region bounded by these two graphs, which we're going to deal with in just a minute. So I'd like to focus though on just one rectangle. So as is our custom, what we do is we first of all try to break this up into a smaller, simpler problem. And the simpler problem is to just focus on the one rectangle. So that one rectangle, and just if you're not sure still what I mean by a triangular cross section, imagine putting a point, it's sort of in the middle. So I'll just do that. And this thing is a triangle. Oh, that's terrible. Okay, here. This is sort of looking down on it. Okay, so it's so that right there, that links up. So this is kind of looking down, but it's a little askew. You have this triangle, so that's poking up in the middle, triangle. And then when you take that triangle, if I had 3D printed a bunch of triangles, you could take that one triangle and set it down on your paper, and it would look like this. Okay, so let's deal with this one triangle. The skinny part is delta x. So I'm going to put the delta x here. I need to know the volume of this triangular solid. So let's just deal with it in terms of what you know. And if we need help, thankfully Easton is here to help us with the formulas. He's a trigonometry expert. But let's see if you guys can remember the formulas. So take a minute and see if you can remember how to find the area of this triangular face. Let's see, get rid of this. And we'll just do the area. We'll call that the base and that the height. So I want to know the area. And the reason why I'm interested in the area is because we all know that the volume of a prism is the area of the base times however thick the prism is. So I'll just do the area of this thing times the thickness. That's what this is. It's a prism. But does anyone know the area for this triangle? It's okay. You can just shout it out. Yeah. Very nice. Yeah. Base times height times 1/2. Probably most of us are more comfortable putting the 1/2 in front. Either way works though. I'm going to put the 1/2 out front. So 1/2 base times height. Perfect. So that's the area of this triangle. And that means that the volume, wait, I'm getting ahead of myself, aren't I? Oh yeah, I am way ahead of myself. I'm right here. Area is 1/2 base times height. We'll answer the questions in just a minute, and then here the volume is 1/2 base times height times delta x, because this thing has a thickness of delta x. All right, has anyone lost their minds yet? This isn't terrible. We're kind of doing the same exact thing that we've done before, breaking it up into small pieces, figuring out the volume, and then adding it up. Hayden, you wanted to make a comment. No, we're going to get to the height in just a sec. Yeah, this is the hard part. So we've got some easy stuff down, and I know some of you are like, what? That's the easy stuff? No, let's get to the height. Yeah. So first of all, let me deal with the base, because remember the base. So let me go back to my diagram, and on the diagram, the base for that triangle is actually this distance. That is the base. So if you imagine, let's see if we can see both of these. Imagine this thing made out of like plastic, a little 3D printed triangle. If you took it and stuck it up there, the base would go from this line up to that curve. So that's this part. Rotated, it sticks there. So what is the base? Can we say what the base is in terms of these curves? I think you can. Does anyone want to do it? I know Hayden wants to. Go ahead, Hayden. No, let's not go there. No integrals yet. I just want the length, the distance. So we'll come back to you, Hayden, because we're going to get to that integral in just a minute. Americo's dying to tell us, what is the length of that base? Yeah, okay, very good. So it's like hearkening back to the area formulas that we did, the areas of between two curves. So it's just from the top to the bottom. Whatever this is minus whatever this is. And what is this? This is some sort of a quadratic. This is some sort of a line. So let's actually write this down. That will be the quadratic minus, 4x minus x squared. So this is the base minus x. And I could even put parentheses to emphasize that. But now that I've got it written down, hopefully it doesn't bother you that I write it like this. So is that all right? Just that's the base. You guys didn't have any questions like why or what, or you thought it was something different? It's a perfect job though, Americo. All right, so once you have that, so notice, I think I mentioned this the other day. I don't know if it was in this class or in a different one, but yesterday I was talking about how oftentimes students think that you go directly from a picture to the final formula with no work. Because in the textbook, oftentimes it happens that way. You have a picture and then a formula, and you're like, where did that come from? It didn't just come out of thin air. It came from a lot of extra steps that aren't written in the book. Okay, so these are the extra steps you'll have to do every time you do a problem like this. Okay, so the expression for the length of the height. So now I'm looking for this. How tall is that? Does anyone know how tall that is? So can anyone guess how tall? Some of you might have a guess. Okay, hey, now I'll let you do it this time. Okay, and so if this is the base, then it's just half of that, right? Okay, so that's going to be 1/2 times 3x minus x squared. Very nice. And now we can deal with this. So this will be base times height, 1/2. So I have 1/2 times 3x minus x squared times 1/2 times 3x minus x squared. Too many sets of parentheses, but there we go. Everything matches up. So just so you know, this is the base, and this one is the height. All right, anyone's mind completely mush? No mushy? It's hard. It is hard. What? I know. Well, we're there. We're almost there. I mean, you could finish this now. In fact, you will. There's just. I just want to point out. Yeah, you're basically this next part is you're just going to rewrite this whole thing. So this will be 1/4 times 3x minus x squared times delta x. All I've done is I've compressed this stuff together, so that's what it looks like. But it's just that's all, right? I mean, just there's the volume. And now you can do the integral. The only thing that I've left off here is the limits. So does it say? It does not say, but you can figure out those limits yourself. So here's your homework for tomorrow. So here, I'll even get this started. Here we are, 1/4 times 3x minus x squared quantity squared dx. You might want to expand this using like FOIL before you do your antiderivative, but you need to, here's what you're going to need to do. So there's a few things for homework. Number one, you're going to need to figure out those limits. That's where these two intersect. Next thing you're going to do is you're actually going to compute your integral. The next thing you're going to do is you're going to back up and you're going to do these two as best you can. And if I'm here tomorrow, I will go over those with you. And then the last thing you're going to do is you're going to bear in mind that I've had on several occasions engineering students come to me, and you guys are free to do this if you want to, because I know engineering is way, way downtown. And so maybe you're on campus and you're like, I don't know how to do this one problem. I love those problems that you do. Come on over to Mathland and show me your problems, because I've been sitting down. I'm like, well, I don't know how to do this, but let's see if we can figure it out together. And honestly, it's so much fun because there have been a couple of times when I'm like working it out and I'm like, wait a minute, we could do this with little increments. And basically it's not, it's similar to these, but it's not exactly in like, we break it up and suddenly we have the integral almost like it comes out after the summation. I don't know, it's been really, really fun. So I'll make that offer. You don't have to come to me, but just if you do have, like you're on campus and you're like, I don't want to go downtown, I understand. And I do enjoy doing physics and doing the engineering stuff. All right, so that's it for today. So just to remind you, tomorrow, just check your email. Check your email in the morning, maybe tonight. The moment I know what's going on, I'll let you know. And then, of course, if I give you an email, then it means that I'll probably put some videos online. Friday, for sure. Well, almost 100%, 95% sure I won't be here, and we will have a proctor. I think Dr. Hewlett will be here. I don't know. Someone will be here though to proctor your exam. You can come a little early, but she does have a class before this, and she has to walk across campus. So whatever. But she might be kind and let you stay a little late, but don't count on it. So you might just want to do your work as quickly as you can. If you forget a calculator, I do have some in the drawer over there on Friday. So that's about it. Hopefully I'm here tomorrow. Well, I don't know. Actually, honestly, hopefully I'm not here tomorrow. So I hope you have a great day, and we